So first of all, I would like to thank AIDA for giving us this opportunity to present our work and being here to talk more about the plant available water mapping using the microwave radiometer technology. But so with my background in engineering, but also in social science too, so I like always to talk about the why behind using the technology and why it is needed for. So I would not like show you something new about the agriculture and irrigation development in southern Alberta. But one of the things that I saw in the Alberta Irrigation Strategy Plan is that we are still pushing the expansion and with the same amount of water that we have to use. And this is like even like since the maybe the 70s or the 80s. And it's not something like particular to Alberta, it's all around the world where like they have been shifting from like increasing the offer into reducing the demand or using the water more efficiently. So for Alberta, like the objective is to increase again like up to 12% or 70,000 hectares by 2025 and achieve that without issuing new irrigation licenses. And so to achieve that, we have to increase our water use efficiency. And yeah, as I said, like to improve that, usually we try also to work more about on the technology or the irrigation application technologies. And the water use efficiency is not only on farm, but it's also from the storage into the farm, like transportation, distribution, and the irrigation application itself. A lot of effort have been done or has been done about the improvement or the modernization of the irrigation districts, like to reduce the losses from evaporation and leakage. And also we can see since the 70s that we had a lot of improvement into onto the irrigation systems used and their efficiency, like shifting from the irrigation surface irrigation systems to the low pressure center pivot sprinklers. We are gaining more than like 30% of the or about 30% of the irrigation efficiency. But these numbers are always still based on the system efficiency, not the irrigation practices. And so the question is here, like, can we, like, when we see the numbers today, we are already like at maybe 90% using the central pivot sprinkler systems, and we are about 85% of irrigation efficiency. But do we still have room for improvement? And the answer is yes, because what we need today is irrigation management tools or decision-making tools that will help the farmers to increase their water use efficiency. And why is that? Because these numbers are based on the optimal or the perfect conditions. Like we have a pivot, we are irrigating the soil condition under the pivot are 100% uniform. We don't have any elevation difference. We have the same soil type and all the conditions are the same. And this is one of the rare areas that I saw these conditions met. So this is really in the middle of the desert in Algeria, where you have the flat soil with only sand. So you are really growing on top of the, let's say, glass, not really soil. So they are using the soil only to support the plant or keep the plant standing there. So we have to provide everything. Like we have to provide the all the nutrient, all the water, and these pivots are running all time. So one of the funny things that I talked about yesterday in a discussion with my friends on the lunch table, it was about the conversion. Because in Algeria, for example, I will give you an example. I will give an extreme example, but just to understand the situation. They invested like more than $300 million to convince the farmers to convert from the surface irrigation into sprinkler systems. And we thought that we achieved like more than 30% of water use efficiency. But at the end, when we went to the field, we found that the farmers are using 3 times more water than before, because they are used to using the surface irrigation and they see the water on top of the soil. So they will use the pivot until they see the water like running on top of the soil, then they will stop. So that's one of the things that, yeah, like if I was a farmer, like I would do the same thing. I'm not saying that they are doing that bad, or I'm not saying also that this is the situation also in Alberta. I know that this is better here, so one of the things that I like about this one, about Alberta, is that the conversion was slowly going from surface irrigation to high pressure sprinkler systems, and then to low pressure irrigation systems. So as I said before, like in the previous slide, we don't really have the perfect conditions. Like the soil moisture is typically fluctuating over time and space under pivot irrigation systems because of the scale. Like we are talking about like 8 spans, so it's like a quarter mile of irrigation distance. And this can be influenced by the soil texture, the bug density, the field capacity, and the wetting point in the different points in the field. And this is the map, for example, of the this is the elevation map of the irrigation pivot that we have in the demonstration farm in Lethbridge College. But the question here is that how can we find like a tool that can help us to face this issue, or how can we improve our water use efficiency? So today we have a technology which is the variable rate irrigation that our colleague from U of A, she was talking about, that there's a lot of farmers who are also adopting this technology. But again, the variable rate irrigation is like the system irrigation itself. It is the tool that will help you to apply the water, but the question here is where, how much, and where we have to apply, and when we have to apply that amount of water. For example, in the demonstration farm in Lethbridge College, we have a pivot that can irrigate up to 2,160 plots with different rates. And to use that at the full potential, we need the information about the variability of the moisture in the soil. Today also we have a partnership with a company called SCAHA Sensing, and this is a research project funded by AIDA. So SCAHA Sensing developed like a tool, which is the microwave radiometer, which is like a sensor that can be mounted on the pivot irrigation system, and that offer a method to resolve the volumetric water content or the soil moisture on the top 50 centimeters of the soil. But is this enough? Like, it's not, because I will give an example. Like, if we have 20% of soil moisture in a sandy soil and 20% of the soil moisture in clay soil, it's not the same. 20%, we are already like above the field capacity in the sandy soil, and we are still not there in the field capacity in clay soil. So we have to combine that, like with soil moisture maps and measurements from about the water retention characteristics, and just to scale up that to a water plant available water map, because that's what the farmer needs as information to make a decision about the irrigation scheduling and the irrigation distribution under his irrigation pivot. So the idea of the project is to convert the VWC maps, like the map that you see on the left of the screen, is the map produced by the microwave radiometer, like interpreting the emissivity from the ground. And by adding the soil texture maps and the water retention characteristics, we can produce a plant available map. And then again, we will introduce the irrigation system efficiency, like, for example, like 89, as I said, I saw in the report, for the low pressure sprinkler system, the road zone depth that may change also during the season, and the VRI resolution of the VRI, or the VRI plots distribution, to have finally a map that can be used by the farmers who already invested into the VRI systems. So yeah, just to let you know that this is a 3-year project that started last year, And in the first year of this project, we focused more on the accuracy of this system, like how to evaluate the accuracy of the microwave radiometers, and how can that be used later by the farmers. So in the demonstration farm, we tested that on 3 different crops, like potato, wheat, and sugar beets. So we had 4 quarters under the same pivot, and then we had 3 radiometer sensors, R1, R2, and 3. You can see them on the top of the slide. And so we had also 2 treatments. So you can see also those squares with different colors. We had 2 different irrigation applications randomly distributed in each crop, and with 3 repetitions, with 100% of irrigation application and a 50% irrigation application. And why is that? Is to determine if the sensor itself can determine if this is a wet plot and this is like a dry plot, and we will see also the absolute values of that too. So we had the data from the radiometer, but we have been also collecting data from the ground. So we monitored the volumetric water content using sensors in the ground, and also doing hydroprobing surveys, the metric potential, and also we had some rain and irrigation depth stations, like onset rain gauges, and a flow meter mounted on the irrigation pivot. So to test that, like we had 8 stations so 2 stations in each crop, and we have been measuring the soil moisture at different depths, like at 15, 30, and 50 centimeters, and with 2 irrigation applications, 50 and 100%, and the measurement frequency was like every 5 minutes. And for those who wants to learn more about the instruments and how we are using this data too, I will invite you also to join the workshop in the afternoon with Dr. Villeman Appeals and my colleague Blair, and it will be really useful to see that. You can just show up, because we don't have registration anymore, but we have a few spots left. So this is one of the stations that we are using, and then we are collecting data and sending that data to the cloud, and then analyzing that data. I will show you some of the results that we received this year, and comparing the soil moisture from the probe-in and also from the microwave radiometer, and checking the hydroprobing surveys in the potato, mainly on the potato field, and I will let you know why later. And you can see also the soil moisture mapping, because we are not yet on the plant available water mapping yet. So this is the graphs of how we managed the irrigation this year. And I don't know if we can see the cursor here, but is it? Yeah. So unfortunately, this year we had really nice and wet June, month of June. So we were not able to push that soil moisture down to have that difference. But since the second week of July, you can see clearly here in the dry plot that the soil moisture went really down, and mainly on the 30 and the 50 centimeters depth, because the topsoil, it's really tough to maintain the soil moisture on the topsoil, and you can see that here clearly that the 15 centimeters was almost in the average of 15 to 20% of soil moisture. So we have been comparing these two, and then we confirmed that on F5, or on the potato field, we have been able to create that gap in soil moisture between the two plots. It was more difficult to achieve that in the wheat and the sugar beets because of the irrigation calendar of the potato. We irrigate more there, so we can create more gap, which is not the same thing with the wheat and the sugar beets. Then we took out this is the 15 centimeters combined data from the soil moisture monitoring stations and our probe every week. And you can see here on the 30 centimeters that we were able to make that gap, like from the second week of July up to the end of the season, and then you can see the 50% how it went down. So we compared that data with the data that we received from the radiometer, and you can see that we achieved the same trend, like we can see the same thing from the radiometer in the same plots. So it was closer here at the beginning of the season because, as I said, like here the VRI system were not doing that work, but from the second week of July we can see that there is more gap in there. But when we plotted the two graphs together, or the two sources of data together, we noticed that the radiometer or the microwave radiometers can distinguish between a dry and a wet plot, but still we have still to improve the moisture absolute values, like to make sure that we are matching the same values that we are receiving from our sensors. Still, there is a limitation in this study because the radiometer is sensing a larger area than the sensor itself, like the probing sensors or the soil moisture sensors. So this may also affect our absolute values too. So the closer we get to them, it's better. But I don't think that the objective is to match exactly the same numbers. Yeah, and that's why this is also the other graphs from the other fields. But as I said, like it was not that good data because we were not also able to push that gap between the dry and the wet plots. One of the things that also we can produce from, as I said, from the radiometer data is the soil moisture maps that can be converted later to plant available water maps. And as you can see here, this is a map from the 27th of July last season, and like the more blue it is, it means that it's more wet, and the red is like the driest. And you can see also like that it's somehow matching a little bit the irrigation applications that we did, because this is the end of the month of July, so the VRI was working and the gap were bigger in different plots. Yeah. So, and why, as I said, like if we go back to the question why it's needed like to have this soil moisture mapping and the plant available water mapping, because today the use of the VRI systems is only based on the static data. Like as a farmer, you know where are the low areas in your field, and you know where are the high areas, so you know that this is more dry, this is more wet. But this is like static data that you can like schedule the irrigation once at the beginning of the year. You may have like a difference in the percentage of the irrigation, but you never know like exactly the depth of the irrigation that exactly needed in that spot during the season, because like the soil moisture, as we said at the beginning, is really dynamic. So what are the next steps, or what are the things that we have done this year too? We worked also on the soil texture analysis in different areas in the field. We did the permeability tests, soil moisture release curves, so just to be able to convert the data from VWC into plant available water. So for each spot or for each point, we can create a curve that we have a VWC as input, and we will get then how much water is available for the plant, because this is the idea. We want to keep the plant in that comfort zone and not stress the plant, just to keep the yield at the highest end. And this is something that you will learn about also in this afternoon in the workshop. So what's next? What's next in this project? Like for the next 2 years, we'll be working also on the the error analysis. We will try to understand exactly what are the gaps, why the radiometer data is influenced, and by what it is influenced. Is it like the height of the crop? Maybe the topsoil moisture may influence also the readings from the radiometer. Then we are creating now, like I'm working now on creating the maps of the different other layers, like the soil texture mapping, like the elevation maps and all the other information, like the water retention curves. And the objective is to start scheduling the irrigation management under our pivot on using or based on the combined data only from the radiometer and the data from the ground. Yes, so for like this is what I have to present for the soil moisture mapping. But I will invite you also. I would like to invite you next week for the irrigation research in RINSA, which is an event that we are holding in Lethbridge College. It's on the 14th of February, so it's next week. You can just scan the QR code, or just look on Google for RINSA in Lethbridge College. So, and you are most welcome to come, because we were talking yesterday about the sustainability also in the lunchtime. And we thought that sustainability is not only about saving water, because so saving water is one of the first things that we have to think about. But saving the water will also make us save other things, like saving on the energy costs, saving on the nutrient. But we are also, at the same time, we are saving the network of the stakeholders and the different actors that we have. So it's also the sustainability of the ecosystem of business, farmers, research, like government and management, irrigation districts. So this event is also an opportunity to bring all these actors together, and we hope to see you next week there. Thank you so much. And if you have any questions, I'm here to answer.
Ryan, EID. I'm assuming would you spin the pivot to take the measurements, and then go around again to water, or are you able to take the measurements and adjust the watering in the same pass?
Yeah. So for now, it's like two questions. So the first question is that yes. So the pivot, the sensor is mounted on the pivot, and you can see that here. This is the sensor. So it's it is sensing like 10 feet. Yeah, no more than that. No, I think 30 feet. Right? Yeah. 10 meters, like I'm a meter guy, so. Yeah. So it's like 10 meters, which is 30 feet ahead of the pivot. So, and we are using, and this is the idea, is like using the movement of the pivot to scan the soil. Like with every round, like with every circle, we get the information about the whole field. And we mounted one sensor in each span almost. So like this, you get more information. For now, we have only 3 sensors, and that's why we are sensing in the last 2 spans. I don't know if there is. You can see here the position of the sensors. So each time we have a circle, we have the data. The second question, for now, we are not like converting the data and applying for the pivot in the same time. It's not a real-time conversion from the VWC to the PAW into the irrigation scheduling, but this is one of the potentials of this technology. Like, if we have the computing speed, or the computing shorten the computing time to resolve all those equations before we can irrigate, it will be the optimal scenario, let's say.
Hey Mohamed, my name is Saad from Intellerain. We also do remote sensing for soil moisture estimation, so I find your research pretty captivating. Thanks for presenting that. My question is that what's the limitation on how much time does it take for your whatever model you're using for water mapping or for soil moisture estimation using the microwave radiometer? How much time does it take from an initial scan of the field using your microwave radiometer to actually processing and getting the final water map or a soil estimation map?
Okay, so I'm not working on the modeling itself, but we are partnering with UFA. We have a team there who are they are working on the modeling of the irrigation scheduling. So they are working on a model that predicts, like from this week cycle, you get the data, and then they can predict in a week how much the soil moisture will be and how much we have to apply as water irrigation. And for now, I think it's about a week to compute the data. Or? A little shorter. Okay. So it still like takes time, but I think we can improve that in the future because we don't have to it can be like a combination between the two models. But yeah, for now it's still taking time. This is why I was saying that we are not that efficient yet on the computing area for now, but I think it's, yeah, we thought about some solutions that may improve that, but we can talk about that in the future. So we can, we will keep you updated.
Yeah, thanks for that. And a quick question, just
For sure.
out of curiosity, how much does it cost to get a radiometer like the one that you're presenting?
Yeah, so you can check on the website of SCAHA Sensing. They have, yeah, so I think that they are doing, they are not selling the sensors, but they are doing like a lease, they are leasing the sensors. So yeah, so they provide the service, they mount the sensor, and they will lease it to you for the farmer or you. So for a season, and then they can also do the maintenance and everything. So you will find more information on their website. It is. SCAHA Labs, sorry, not SCAHA Labs, Sensing. Yeah.
Thank you.
Yeah, no problem. Sure.
On behalf of our irrigation district, the BRID, I'd like to thank you for what you're doing. We're hearing there is great demand for more irrigation in our district, so we can't make any more water, but this kind of technology and what you're studying and what you're doing will enable us to irrigate more acres. So we really appreciate this. I know, you probably got a long ways to go, but it's working well, I think. And,
thank you.
And it's good to see. So I wanted to pass that message to you. Also at our table, Vic asked the question, and maybe, I don't know if you have the answer, but some of this technology, like these valves opening and closing and then, different rates, was there issues with them in what your study was doing here, or did they work really well? That's a question he was wondering about.
For sure. That's a really good question, because I had to go to the field and fix some stuff on the VRI because of that. Because today there is two systems there's two. Yeah, what I know, that there's two VRI systems, like for the closing and the opening of the valves. So there is the pressure system, and there is the electronic or the electric valving system. So with the one that we have is the pressure one. So you really have to keep all the nozzles like clean and working well, just to keep that pressure high. That will give enough pressure for the valve to close and open. But still, like with the maintenance, it can work. And we will be investing I hope that we will be investing into more, I don't know if I can say that. Yeah, you can say that? Okay, sounds good. Like for more advanced variable rate irrigation systems that uses like electronic valves instead of the pressure ones. So you will avoid the issue of the low pressure to close or to open the valves. So that's a really good question. Thank you so much. Yeah.
This question, I guess, is regarding, were you just mostly testing the technology or the equipment, or did you track the effect of a canopy in terms of maintaining plant available moisture, which is quite variable through a growing season, and you could see that with the crops that you had, the effect of the plant canopy in terms of protecting water and the efficiency that is potentially available by managing that to the extent that you can. Was there any work done on that or tracking on it at all?
Could you please repeat the first part of the question? Was it like, are we like
the question
checking the canopy or checking the soil? Or?
The effect of the canopy in terms of protecting and providing available water, soil or plant moisture right? I mean, if you got a canopy, you're not losing as much on an ongoing basis. And that changes with the season, but I just wondered if you were tracking the impact of the canopy, because that has over time, a fairly potential impact on water efficiency use and the amount of water that's needed to get to where the plant can use it.
No, that's a really good question. So what we have been monitoring is really the data inside the soil, like the soil moisture straight right from the ground. We didn't like investigate into the effect of the canopy on that like yet, but this is a good thing to maybe to think about for the future, for the next step of the project. Yeah, that's a good question.
Sorry, I just had a couple of questions about your research. Sure. The first question was, I was kind of curious how much water is applied at a time when you're doing research plots like this, as far as depth of application. And my other question was, and in the research realm, do you have to compensate at all for pivot sprinklers that move continually compared to ones that move on a time cycle? I know one pivot manufacturer advertised continuous motion compared to the other, which I'm not terribly a fan, just to say I'm not selling that kind of pivot, but just when you're doing small plots like that, the stop and start, I was wondering if it had any influence on the research you have to do.
Yeah, I'm not sure if if the stop and start are equipped with the VRI, but yeah, so the one that we have in the demonstration farm is a continuous movement like pivot. And so I would go back to the first question. So for the irrigation applications depth, it may vary based on the plant needs. Like we were using a model to see how much water we have to apply in each irrigation application. But I would say that we were varying from like 0.5 to 1 inch in each application. The second question was about if the VRI works in the two conditions, or?
Just you have to compensate for continuous motion compared to a pivot that moves in stages. Is part of
Yeah. No, I think because when it's moving, like the idea of the VRI is that the valves will be closing and opening in the like in less time. You can see that on this picture. So for example, like this is a plot that it is irrigated like for 100% application, and this is a plot that it is irrigated for a 50% application. So when the pivot is moving and it arrives to that plot that you want to irrigate for 50%, let's say like the time needed to apply I'm just saying, so if the time needed to apply 1 inch of irrigation is 10 minutes, when it arrives there, like every minute, what it will do, it will close the valves 1 minute and open the valves 1 minute. Close 1 minute, open 1 minute. Like this, it will be given time, given the irrigation depth, half of the time of the plot, which is at 100%. And why is that? Like why it is not only applying 50 and then it stops? Because we need always to have at least 60% of the irrigation application running in the pivot, on the long of the pivot, just to keep that pressure at the normal level or the optimal level. So that's why so you have a zone that will shut down and then another zone that turn on and off and on, off and on, like I just give an example of 1 minute, but maybe it's 2 minutes or so, but this is how it works. Yeah. Yeah, so thank you so much.